Okay, and let me share my screen. Can you see my screen right now?
Yes, ma'am.
Okay, great. All right, so I just post the announcement in here. You can see like from Monday, next Monday will be our week 4 already. Okay, so that kind of things. If you look at the chapter 3 test, it's gonna be due by Wednesday. Okay, one thing is not chapter 3, chapter 2 test will be due by next Wednesday. Okay, chapter 2 will be the test 2. All right, so we don't have time to go through every section little detail, but I think the best way to review this one is go through the entire chapter review. Okay, this one is a little bit random order, but pretty much cover every section. You can have a 2.1 right here, 2.6, 2.2, and then 2.3 right here. Okay, and then that's 2.1. So this one is not necessarily in the exact order for the section, but it will miss everything, and that's pretty much the test question you will have, right? It's a random order for the chapter. Okay, so this chapter is about all the quadratic. All right, so let me just give you a very quick review for the quadratic before we start doing the question. All right, so the standard format for the quadratic is ax squared plus what? bx plus c equal to 0, right? And there's a formula for this x-intercept, which you can have a one page of the formula sheet for the test. Okay, so the x-intercept, this one is making y equal to 0. So we have y equal to 0, right? This whole thing is y. Y is equal to this whole thing. And we're making this equal to 0. So basically, we are looking for the x-intercept. All right, so what does the x-intercept mean? That means the graph passing the x-axis, right? So look at like this one right here. I have a 2 x-intercept. Maybe this is -1. Maybe this is 2, right? So the point here, this will be 2 and 0. The coordinate here, this one will be -1 and 0. And this is called x-intercept, okay? And then this one is x-intercept in here. And x-intercept, we have a several way to find this one. We can make this whole thing equal to 0. One way we can do is by factoring, right? If you can factoring quadratic equation, maybe the easiest way. Not quite easy, but the fastest way to find the x-intercept. Another one is the formula. So what's the formula? The formula will be negative b plus minus square root of b squared minus 4ac over 2a. Again, if you don't remember this formula, this can be only one page formula on your own, okay? Only one page, not 2 or 3. Not going to the note and looking around everywhere. So you will need to prepare one page formula sheet. I will let you prepare on your own, so give you a little bit more flexibility, okay? You can write down as many formulas as you want in one page, all right? So that is the factoring. If you want to calculate this whole thing, you will have to use the entire formula, right? And then b squared minus 4ac, there's a name for this one. It's called determinant. All right. If this is greater than 0, like this one, you will have a 2x-intercept. Okay. You have a 2 solution. Okay. Two solutions. And then this is, that means you have a 2x-intercept. All right. And then if you have a b squared minus 4ac equal to 0, you're going to have just one real, one, this kind of situation. All right. So you have this one touch this x-axis. Okay. So you only have one x-intercept in here. All right. If this whole thing is less than 0, that means no x-intercept. Okay. No x-intercept at all. So what kind of situation you don't have an x-intercept? Well, you maybe this graph maybe above the x-axis and facing up. So this kind of situation, it never touch the x-axis, right? So this is not intercept. Or you can have this graph facing down, but below the x-axis. So in this kind of situation, if b squared minus 4ac would be a negative number, that means there's no x-intercept. All right, so that is a very important one for the x-intercept. The other one, don't confuse with this one, is the vertex. Okay, so this is the lowest or the highest point. This will be called a vertex. All right, and only this kind of situation, you vertex right here. You vertex right here. Only in this kind of situation, your vertex will be exactly the same as the x-intercept, right? Because this only touches the x-intercept one point. So this one is your x-intercept. This also is your vertex. And those are very, very rare situations, probably only 5% of the chance, okay? In this one right here, even you don't have an x-intercept, but you still have a vertex right here. So vertex for quadratic always exists, okay? That is the vertex right here. All right. So the way we find the vertex is very different. You cannot use this cannot be using to find vertex. Okay, because that is this one. This formula is finding the x-intercept. This cannot use to find the vertex. All right. If you have this equal to 0, yeah, you have to go to look at if this one equal to 0, what happened? Well, if this is equal to 0, my x will be negative b over 2a. Look at that. This whole thing, if this whole thing is 0, my x will be just negative b over 2a. And that is the one we find the vertex, actually. So we have a vertex formula. All right, so what is my vertex formula in here? My vertex formula, x equal using negative b over 2a. And then what is my y value? You just plug whatever you calculate this x into the y, into the function. And then you can find the y value, okay? So this is f of x is equal to a squared plus bx plus c. All right, so that's using the vertex formula. Of course, you can completing the square to find the vertex, right? So that's the vertex formula. But we also have a called a vertex formula. So what is the vertex formula in here? The vertex formula here is if I can write down my f of x is a times x minus h squared plus k. This one is completing the perfect square. Look at it. This one is not a perfect square, right? If I change this whole thing into this one, you will need to complete a perfect square in here. Now you can find the vertex will be just h and k, okay? So if the quadratic equation is in this form, I would recommend using the formula, vertex formula, negative b over 2a. If the quadratic already in this vertex form, you can find a vertex in this form already. So you don't have to expand into this one and then using the formula, right? You take the easy way. This you can find a vertex right away. All right, so those two are the most important character for this chapter that you will need to be very, very clear, okay? So do not confuse the vertex and the x-intercept. The only thing vertex will equal to the x-intercept is when b squared minus 4ac equal to 0. When the quadratic only touch the x-axis, okay? Only touch it at one point. Any question about these two? All right, I just want to give you a quick review for this one. So let's look at this one right here. This one asks you to complete a square and then find a vertex for this quadratic, okay? Another thing is this vertex, you can also graph this one and then put it in a calculator, right? So let me see, I can open the calculator. All right, so open the calculator. If you graph this one, at least you can see where your vertex locate, in which quadrant. All right, I just want to clear my statistic plot. So you want graph the statistic part. All right, so let's look at the my y equation is x squared minus 10x plus 98. Okay, all right, so I will graph there, and then if you didn't see anything, I can go ahead and zoom free. Okay, like to using a zoom free. Oh, zoom free doesn't see that much, so I can adjust my window a little bit. Okay, this one is a really big one. All right, so still couldn't see the entire graph right here. So maybe I want to increase my x a little bit more. Okay, so let's increase x, and then y minivan, let's say negative 20. Okay, just kind of trying to see the whole thing. All right, so now we can see the whole thing that way. So you can see this one vertex is in the fourth quadrant in here. You can see this is 1, 2, 3, 4, right? Q1, Q2, Q3, Q4. So this is the vertex. And looks like this graph is above the x-axis, all right? So if we're trying to find the x-intercept, this b squared minus 4ac will be less than 0, will be no x-intercept in here, all right? But looks like a vertex is in the fourth quadrant. So both you x and y should be positive. Okay, at least we know that part in here. All right. So let's see how do we complete a square for this one. We said earlier. I say using the formula, but in this case it asks us to all right, I just close that one. Let me go ahead and then. Okay, I'm trying to get this one a little bit bigger. Okay, so we can do it from here. Let's go to look at the first one right here. We want to have a f of x equal to x squared minus 10x plus 98, right? So I want to complete into this form, okay? Complete into this form. A times x minus h squared plus k. So that's called completing the square. Since my coefficient of the a is 1, so I will need to just add a number. All right, so I will need to add a number and then minus a number. And don't forget, I have a plus 98 in here. This is called adding a 0, okay? So what is adding a 0? If you plus a number and then minus a number, that means you just adding a 0. Your value is still unchanged, okay? So that is the one we want in here. So how much I need to add in order to complete a perfect square? Okay, how much I need to add in here? The key thing here is you add half coefficient of the x, and then so half coefficient of x. The coefficient is negative 10. I'm going to use the positive one because I have to square them. Okay, I have to square them. So when you square them, it will be positive. So that way, I just need to take the number only. I don't have to keep the sign. So this will be 10 over 2 will be 5. And then I add this is 5 squared. Okay, so this through it will become a perfect square. All right. And this one is called adding a 0. Look at 5 squared and 5 squared cancel out, right? So basically, I didn't add anything in terms of the previous one. And this will become x minus 5 perfect square. These are 3 terms, okay? And then you go ahead calculate these 2 terms. So this will be minus 5 squared will be 25 plus 98, all right? And then this will be x minus 5 squared. You just add these 2 together, So this minus 25, you got 73. All right. So now if you compare this one right here, I have a x minus h squared plus k. So my vertex here will be just 5 and 73 because this is minus h. H here is positive. Okay. So that's exactly, so that's in fourth quadrant in Q1, which is exactly right because we just graph them and make it, that's the fourth quadrant. All right. You don't have to graph this one to be able to find this one right here, right? Any question about this one? Completing the square. So basically, if you have an x minus a square, okay, this is equal to x squared minus 2ax plus a squared. And then we do the opposite way. We want to have 3 terms become the 2-term perfect square. All right. So since you have if you go to do the FOIL, it will become this term. All right. So that is this one. That's why when we try to add the middle one, we add half of 10. Okay, and then square. All right. So that way you will find the A. Okay, so this will be your A in here. All right. Any questions about this one? Okay, so number 2, what is the maximum number of x-intercept that a polynomial of the degree 14 can have? All right, so if you have the x-intercept, look at that, this is quadratic, right? The quadratic I have the most, look at this quadratic I just dropped right here. I have this quadratic is a degree of the 2, right? The most x-intercept I have here will be the 2. I can have a 2 x-intercept, or in this case, I have only 1 x-intercept, right? And then in this case, I have a 0 x-intercept. So I can have this quadratic, I can have a 0 x-intercept, I can have a 1, or I can have a 2. 2 is the most one, okay? So the most or the maximum number of the x-intercept is just equal to the number of the degree, will be the 14. Okay, so that will be just 14 in here. All right, number 3, indicate whether this specific graph is a function or not. Anyone give me an answer? Is this a function? The graph does specify a function or not? A is yes, B is not. Give me an answer, everyone.
Not a function?
Why is not a function? By the way, that's a correct answer. Yeah, but why is not a function?
It doesn't have like a dot to coordinate a specific number, and the line it ends without like the little arrow. But
Oh,
that's what I think. I'm not sure.
okay, so that is partially correct only. Okay, so in order for a graph to be a function, we say have to pass a vertical line test. So what does that mean, pass a vertical line test? You drop a vertical line, it only passes 1 point. Okay, and then if you look at this one right here, something like that, right? If I drop a vertical line right here, it passes 2 points. If I drop a vertical line right here, it passes 2 points. So look at that. This graph is a function because I drop a vertical line, it only passes 1 point. It only passes 1 point. All right. So regardless what is this ending, this one is not a function because it didn't pass the VLT. All right. So what's VLT? Vertical
line test.
Yes. All right. Vertical line test in here. Okay. So this one is not a function because it did not pass the vertical line test, VLT. All right. Okay. Number 4, you want to write down this equation using this graph. Okay, so we need to indicate whether it's A is -1 or +1, and the H and the K are integers. So that means we want to using this graph to write down this equation. Okay, so we can make it a little bit bigger in here. And let's look at this one right here, where the A be positive or negative.
It'd be negative.
Positive.
Well, this graph or this quadratic is facing down.
Oh,
So that
down.
means, yeah,
Negative.
it's so A should be
Negative.
negative. Yeah, negative. Negative is facing down. Okay. So if this A is negative, it's facing down, positive will be facing up. All right. And this is your vertex. So the vertex here, let's make it, okay, make it even bigger. Let's see, where's the graph? All right, now we can read the graph. Okay, so let's read this graph. X will be negative what? Let's see, that is 1, 2, 3, 4, 5. Looks like X will be, H will be -5, right? And then the vertical one, let's say 1, 2, 3, 4, 5. This will be what? 6. So my H is what?
Say -5.
Okay, yeah. H is -5. H, K will be what?
6.
6. Okay. And then A is -1, right? It's facing down. All right. So can we plug this whole thing into the formula? My formula here will be A times X minus H squared plus K. Okay, so what is this formula?
This is the vertex formula.
Yes. All right, so X minus H. H is what?
5, -5.
-5. So this will become what?
Positive.
+5.
Yeah, +5. And then what?
So plus K, and so 6.
Plus 6. Yeah. All right, so look at it. This is this kind of equation. All right. And by the way, if I give you this equation, you should be able to kind of graph this one, right? This one, you're going to be able to find the vertex will be -5 and 6. Okay. And then A, this one is negative. All right. So you can locate the vertex right here. All right. So that is using this called a vertex formula. So you can write down the equation, right? And then you read the graph. So this graph, you need to understand this vertex is in H and K. And H is -5. So minus a -5, you're going to be +5. Okay. K is easier. K is just plus K. So whatever you K have, it's just, when this K is positive, you just plus K. When K is negative, you minus K, right? But inside this parenthesis, you have to be very careful because this is using minus H. So when H is negative, you actually have a +5. Okay, number 5, we'll find the domain and range of the function. Okay, domain is all the X value that a function can have. And we know this domain, we usually say domain is only have 2 rules, right? So what are the 2 rules for the domain? Domain only need to satisfy 2 rules. One is if you have a denominator. So rule number 1, I usually tell people, say this is a no. A number divided by 0 is a no. That is undefined. Okay. And then if you have a 0 divided by a number, that is okay. All right. So if you remember the no and okay, this one is okay. It's equal to 0. A 0 divided by a non-zero number is always 0. Okay. And then if you have a number divided by 0, that is a no. So remember, these two words will be very helpful in this one. So my denominator here is x minus 1. X minus 1 cannot be equal to 0. That means x cannot be equal to 1. So that's rule number 1. Rule number 1 for the domain is denominator. Denominator cannot be 0. Okay. All right. Rule number 2 is if I have this is under the even root. Okay. If this is even root, the R root will be okay. Only the even root. Radicand cannot be negative. So what does cannot be negative mean? All right, radicand is, that means everything under the root is called radicand. So my radicand here is x minus 2. All right, this cannot be negative. Cannot be negative, that means cannot be less than 0. So must be greater than or equal to what? 0. Okay, and then you go to solve for x, add a 2 on both sides. So x must be greater than or equal to 2. Greater than or equal to 2. If you write down in the interval, it will be from 2 to infinity. Okay, this one, if you write down in the interval, I had to circle 1 out, but this can be anything to the left and anything to the right. Okay, so this one will be negative infinity to 1, and then union from 1 to infinity. All right. Okay, so that is the domain. That is the domain for this one. Okay, and then this is the domain for this one in here. All right. So if you put this one right here, you can actually see the domain from the graph. Okay, domain is in a real number, and then if I graph y equal to square root of square root, so second x squared will be square root of x minus 2, right? If I graph this one right here, let me zoom standard. All right, so look at this one right here. My x here is starting from 2. X cannot be 0 or negative in here. Look at that. This graph is starting from here. All right. If you're using the second graph, you can see the table. Okay. So when x is less than 2, these are all giving you an error. Look at it. This is all error. So that means x cannot start from minimum value for the x should be 2. Right? When x equal to 2, y will be 0. And then y can be increasing from here. All right. And then you can keep going on and on. Okay. So that is the domain. Domain is the x value that you can see from the graph. So my domain is from 2 to infinity. And what is my range? Well, range is the y value. So y value, you can see, even you can see from this value in here, I have a minimum value of the x is 2, so the minimum y value is 0. Okay, and you can see the graph, is starting from y is this point, y is 0, and y keep going up. So it's an increasing function here. All right, so that is my domain in here, and my range for this one, right? My range for this one will be from 0 to infinity. Okay. All right, let's look at our graph in here. This is the absolute value of x. So my x is not in the denominator, is not under the square root or fourth root, any even root. So if that is the case, my domain x can be all real number. Okay, the interval notation, all real numbers. So how do you write down all real number in the interval? It's negative infinity to what? Positive infinity. Okay, so this one is all real number. All right, and then we have an absolute value of x. This is negative 6 plus 4. Okay, so we know like I'm sorry. We know the positive number absolute value will be still positive, right? And then if we have a 0, absolute value will be 0. if I have a negative 2 value, absolute value, this one will be still what? Positive. Okay, so everything come out from the x, everything come out from this absolute value of x has to be greater than or equal to 0. All right, so my minimum value here is 0. My minimum absolute value of x is 0. So if I have 0 times negative 6 is still 0 plus 4. So my minimum y here is 4. Okay. So that is the domain of the function domain here. Domain here is all real number. Okay. What is my range? Well, my range here will be, since this one will be always greater than or equal to 0. Well, actually, I take it back. This should be my maximum instead of minimum. You know why it's maximum? Because this is facing. This is my maximum. All right, because when this is greater than 0, if you plug a absolute value of x equal to 1, when x equal to 1 in, okay, this whole thing, f of the 1 will be what? Negative 6 times 1 will be negative 6 plus 4. This will be negative 2. Okay, so anything you plug a non-zero in, this whole thing gonna be less than. So if I graph this one right here, I have a x is 0. Y will be y will be positive 4, so it should be right here. Okay, so this is 4. All right, and then this whole thing will be facing down like that. All right. Okay, if you do not really know how to analyze this one right here, you can put it in a calculator. Calculator will graph for you, and you can see which one is the y value. Okay, so let's put this whole thing into the calculator. All right, I have a negative 6, so the first number is negative. You need to use the parentheses here. Okay, negative 6, and then times the absolute value. So where do I find the absolute value for the x? You will have to go to math, I think, and then I'll go to number, okay, and then the ABX is the absolute value. All right, so now I have an absolute value of x, right? And then we have to move out and then plus 4. Okay, so that will be how you exit the absolute value. Go to math. All right, when you go to math here, you will need to go to the second one using the number. So now you have an absolute value in here. Okay. All right, and then we're gonna hit graph. Okay, we're gonna go ahead hit graph. Now you can see this one it is facing down, right? So it's kind of like a little bit like a quadratic when the coefficient is negative, it's facing down. And then this is moving up for 4 units compared to y equal to absolute value of x. All right, so this y value equal to 4 is the maximum. Look at it, y will be all going down from this point. Okay. All right, so how do you write down your range in here? Well, your range here will be from negative infinity to 4. It does include 4, so you have to use the bracket. Okay, so y is less than or equal to 4. All right, so that is your y value. Questions? All right, so that is 2.2 in this one. Okay, you can see we just review this one is the equation. That's 2.3. This one is 2.1, right? And then this one is 2.4 and 2.3. Okay, so that is the one we review. All right, and then this one is your 2.6. So make this chapter a little bit more challenging. Here is you also have a exponential and logarithm. Okay. And I do allow you to use one-page formula for the logarithm formula if you need to, all right? Okay, so you want to solve B without using a calculator. Okay, so how do you solve B not using a calculator? we have a log B of 1296 equal to -4. So that means I will need to convert this one into exponential equation, okay? So how do you convert? I usually tell people, say, just drop a circle, all right? Drop a little bit, kind of like a circle that way, okay? So start from the base. Base stays the same. What does that mean? Base stay the same. That means this b is the base in a logarithm. When I convert it into exponential, this b is still the base of the exponential. Okay, so this is the base. This is also the base for the exponential. And then this is b gonna raise to the power of -4. Okay, and then we are equal to 1296. B will raise to the power of -4. We are equal to 1296. So now we have this one become exponential function. Okay, this one become a exponential function in here. So that means I am going to write down this b to the -4 is equal to 1 over b to the +4 power. Okay, if I want to put it in a +4 power in here. All right, so that is, so 1 over b, 1 over b to the 4 power will equal to 1926. So that means I'm going to break down this 1296 into something to the 4 power, right? Look at that. If I have a of m equal to a of the m, so m and m must be equal. M and m must be equal. On the other hand, if you have a of b of m power equal to c of m power, so if the power are the same, the base must be equal, okay? If the power is the same, the base must be equal in order for this whole thing to be true. If you have a same base and a different power, well, not different power, if you have a same base, in order for this exponent to be equal, your exponent must be, in order for this whole thing to be equal, the exponent must be equal, okay? So you have the other one are the same, and then you want to be equal. The other one also need to be the same. Look at that. If I have a 3 square, equal to 3 square, right? So that kind of thing. So the base and the exponent both has to be equal, the same. All right. Okay. So now let's go ahead do this one right here. So that means I'm gonna break down this one into power of 4. Okay. And then if you do not know how to break down this into power of the 4, we can give you a little bit divide. You know, this is an even number. The even number can be divided by 2, right? So if I divide it by 2, let's see what we got. This will be 6, and then this will be 4, 8. Is that right? Anyone have a calculator? You can double check on me. All right, and then if I divide it by 2 again, what do I get? 324. If I divide it by 2 again, 162, right? Divided by 2 again, I got 81. Okay, so, and then 81 cannot be divided by 2, but can be divided by 3. So 3 divided by 3, this will be 27. Divided by 3, this will be 9. Divided by 3, this will be 3. All right, so I have this big number. I just break down into this 3. So this one, you have 1, 2, 3, 4. You have 4 of the 2, so this can be 2 to the 4 power. Times I also have a 4, 3, so this will be 3 to the 4 power. 2 times 3 to the 4 power, I can have a 2 times 3 to the 4 power, or 6 to the 4 power in here. Look at that. So I have this one is a 6 to the 4 power. Okay. So what does that mean in here? That means my Okay, so I have 1 over b to the 4 power equal to 6 to the 4 power. So that means my 1 over b must be equal to 6. Okay, and then you go to solve for b. So multiply both sides by b, you have a 6b equal to 1, or b will be 1 over 6. All right, so this b here will be 1 over 6. A little bit tricky on this one. So first, you have to convert it into exponential equation first, and then go to find the same base as, same base, using the same power, right? So you have to go to find a b to be the same base. So in order for this one to be here, is 1 over b must be equal to 6. Questions?
That one kind of confuses me.
Okay.
Is it more of a simpler way to break it down from the tree instead? Or
Okay, all right. So you can use the calculator. Okay, so if let's see, 1296, right? You can using the calculator say if I divide by 6, what do I get? Oh, I got 216, and then you divide by 6 again, you have a 36. If you divide by 6 again, I got 6. All right, so that means you have a 4 6 in here, so you have a power of 6, or you can just look at it, 6 to the power of 4, right? 6 to the power of 4 will be equal to what? 1296.
oh, okay.
Okay, you can use this one. 6 to the 4 power is 1296. Using a calculator, make it a little bit easier. Okay. And the way I show you this one is I have no idea to begin with, and then I just knowing this is an even number, and then I trying to break down even number can be always have a power of 2, right? But if you know this is kind of, you can give it a try. You can try 2, you can try 3, you can try 6. In this case.
Okay.
All right. Okay, find and simplify the expression if f of x equal to x squared minus 6. So you want to simplify this expression. So basically, you just replace the x. Whatever you have an x in here, this equation, x is a variable. Variable, that means the x can be changed, right? So the first one, will replace the x by 4, okay, and then calculate this whole thing. The second one, I will replace the x by h, and then this will be just h squared minus 6, and then simplify your answer in here. Okay, so how do you do this one right here? Well, first you do the so that's number 7. You do the f of 4, right? You have a f of x equal to x squared minus 6. So you calculate f of the 4. So f of the 4 replace the x by 4. So that be 4 squared minus 6. How much is that? That would be 10. Is that right? And then you calculate f of h. So how much is f of h? Replace this x by h. So what do you get?
H squared?
Minus 6, right? Yeah, you also need to minus 6. You have to look at the entire equation. So you just replace the x by h, okay? And then copy it down whatever you have. All right, so if I want to do the addition, so you have to have a 3 step. First step, find the f of 4, and then find the f of h, right? And then you just add these 2 together. So you have a 10 plus h squared minus 6. So this whole thing will be h squared plus what? 4. That will be the answer. Okay, this PDF won't let me write, but so you have this the whole thing will be just h squared plus 4. All right. So basically, you just plug, replace the x by whatever the value inside the parentheses, and then calculate, and then combine the like term. Any questions? All right, so this is from the 2.1, okay? Just the function notation in here. This one will be the exponential equation, okay? So remember that x to the negative, e to the negative x power is not equal to 0 for all value of x. That is an exponential graph, right? Okay, so we want to solve for x in here. Okay, so let's see. This one look a little bit complicated, but actually it's not. All right, so how do you solve this one? Oh, we have a e to the negative x, factor it out. Common factor, we take it out, right? And then we're gonna have a x plus 5 equal to 0. All right, so if you have a two-factor multiply, if you have a times b equal to 0, the only thing you want to be 0 is one of the factor is 0. You either a equal to 0 or b equal to 0. Okay, so this is multiply. Okay. This whole thing you can have so this is two factors. You can have e to the x minus e to the negative x equal to 0 or x plus 5 equal to 0. But this equation already giving you said, remember e to the negative x is not equal to 0. All right, so this is not equal to 0. Okay, so the only thing can be 0 is this one. All right, so you don't have to solve this one right here because this will never go to 0. All right, even remind you this way. So this will be just x equal to negative 5. Okay, only one answer. All right, look at that. It said, remember e to the negative x is not equal to 0 for all value of x. Okay, and you know why? If you go to graph y equal to e to the negative x, it will be something like that. Something like that. Okay, this is y equal to e to the negative x. And this is a decreasing function, but this one keep going on and on, but it never touch the x-axis. All right, so that's why it's never going to 0. This one is 0 and 1. Okay, that's a decreasing exponential function. All right, since this one never go to 0, so you factor it out. The only thing can be 0 is the second factor, right? This first factor never go to 0, so only the second factor can be 0. All right, number 9, we want to find an equation, any horizontal asymptote for the function below. Okay, horizontal asymptote is the graph where when x is going to really big, y gonna become a fixed number. So that would be the horizontal asymptote. So if you look at this one right here, this numerator degree actually is 1 degree higher than the denominator. So basically this one doesn't have any horizontal asymptote. It will have a slant asymptote, but it doesn't have a horizontal asymptote. Okay, so this one is function don't have a horizontal asymptote. The only thing the function will have a horizontal asymptote is they have a same degree, okay, or lower degree. If I have a x minus 19, if I flip this one right here, right? If I flip this one, so this is an update. If I update this one into this one, now I will have a horizontal asymptote. So my horizontal asymptote here will be y equal to 0 because this degree now degree is lower than here, okay? If I have this is the same degree, what happens? Well, if I have this is the same degree, my horizontal asymptote will be just the coefficient of these two. the ratio of the coefficient. So that's 1/1. This will be y equal to 1. Okay. All right. So that is this one right here. I usually tell people, say, how do you find a horizontal asymptote? You usually make sure you have a if you using the ratio of the coefficient will not have the same degree. Okay. So why this one don't have a horizontal asymptote? Because let's see. If I make it this to the same degree, okay, x is squared plus 2x plus 2 over x minus 19, right? So I have a higher degree here is 2. So I will make the 0x squared in here, okay? So that way I just add a 0x, so that means this is still 0, so I don't change the value for this whole thing, right? And then that way I can find my horizontal asymptote will be using the coefficient of the highest degree, which is x squared. And then divided by this one, even I don't have a x squared in the denominator, but I can make up to a 0, x squared to get it to the same denominator, same degree, but still not changing the value. And remember, this one is a no, okay? A number divided by 0 is a no, or undefined, all right? So what does undefined mean? That means there's no horizontal asymptote. Okay, so you can using the same degree for 3 different type of situation, or you can just go to remember all 3 little details of the horizontal asymptote. All right, questions? Okay, rewrite the expression in the equivalent logarithm form. All right, how do you rewrite this one in the logarithm? Number 10. Or you can have a 2q equal to a, right? So that means what is my logarithm? I have a b raised, look at that. This is the logarithm equation. If I have a base b, and what does this logarithm mean? If you drop a circle, so that means base b raised to the power of n will equal to x, okay? The base b raised to the power of n will equal to x. So we said earlier the base stay the same. This 2 is the base. All right, it will be the base in a logarithm. Okay, so where does 3 go? 3 is to go to the right hand side. Okay, so you have a log 2 of a is equal to 3. Okay, so you can see this exponent is the answer of the logarithm. All right, if you do not know, draw a circle, trying to see you can get it back. 2 raised to the power of 3 equal to 8. Okay, start with 2, and then you have to go to the right hand side, make a circle. 2 raised power of 3 equal to 8. All right, so the base stay the same. Base is 2 here, base is also 2 here. Base stay the same. All right, so 2 raised to the power of 3 equal to 8, and then log of the 2 you know raised to the power of 3 in here equal to 8. Okay, any questions? So if you just need to remember this format in here, okay, this actually is the conversion. Convert a log into exponential, or convert an exponential into log. All right, number 11. Let's see how many questions we have. We have about 15 questions in this test. Okay. All right, so this is called a piecewise function. So the reason is a piecewise because you have a limited value of the x. Okay. In here you want to choose the correct graphing. I couldn't copy all the A, B, C, D in here, so it missed some of them. But we can graph on our own, okay? Once you can graph on your own, you can choose the correct answer. All right, so that is called a piecewise because your x actually have the limit value, okay? For the first piece, x should be less than -1, but do not have an equal sign, okay? The second one, it does have equal sign in here. So these are all straight line, right? So actually, it's not different than graphing the whole thing. You just have to limit the x value, okay? So I am going to give you a little bit of value in here. Let's go ahead. If I want to find f or the 0, let's see if you can find these 3 answers. All right. How much is my f or 0? I'm just adding on the top of this question. Okay, so how do you find my f of the 0?
You just replace x anywhere you see it with 0.
Well, you have to look at which function do you use. You look at the first piece or the second piece for the f of 0. So that means you want to look at the domain for the 0. Is 0
Oh,
less
so you'd
than?
want to do the second one?
Yes, okay, because 0 is greater than or equal to what?
-1.
Yeah, so we're gonna using x minus 2, this piece, and then replace the x by 0 in. All right, so that would be -2, right? And then if I want to find the f of the 1, which piece do I use?
Still the second one?
Still the second one, because 1, you look at the 1 is greater than 1 is greater than or equal to -1. 0 is greater than or equal to -1. So you're gonna use the second one. So this will be 1 minus 2 of what? -1. Okay. And then f of the -2, which piece do I use?
You use the first one.
You use the first one because -2 is less than what? -1.
-1.
Yeah. So that one fit into the domain for this one. So you're gonna use the first piece, 3 minus 2x, right? And then you're using x is -2, plug it in. Okay. So negative become positive. All right. So this will be equal to 7. All right. So that is the difference of the this one right here. And I can graph. So if I have a f of the -1, which piece do I use?
You would still use the second one.
You use the second one because this one has an equal sign, right? So this one will include a -1. So you have a I'm sorry, f of the -1. Yeah, so you're using the x minus 2. Okay, so x is -1 minus 2, this will be -3, that kind of thing. So basically, which one do you use? You have to look at the domain to fit into there. All right. So we can graph them. Okay, these are all linear, so we only need 2 points for each one. Okay, so I can go to graphing, and then after you graph on your own, you can choose the correct one. Okay, so I have a 0, I have a -1, +1, 2, 3, -2, right? And then this will be 1, 2. All right, so look at that one. This is that separated by -1. So I'm gonna go ahead and give you a little bit kind of help me to identify this graph. Okay, this is my additional line. This is not part of the graph. Okay, I'm gonna just drop my vertical line for the x equal to -1. So that means this piece start on both sides, right? So one piece is x, it will be less than -1. So this x less than -1 will be from here to the left. All right. So let's see, when we have x equal to -1, we can have a -2. We can graph this one right here, right? So we have a -2, y actually is +7. So -2, y actually +7. So probably somewhere right here. So all right, so that is my point, right? So the -2, and 7. Okay, and I can also be -3. Okay, I can also be -3 because -3 is also less than this one. -3, this, give me a little bit more space in here. All right, let's see if f of -3, right? We're gonna using the fourth piece. Okay, so that's -2, -3, 6, that would be 9, right? So -3, this will be 9. Okay, -3, this will be 9 right here. All right, -3 and 9. Okay, so I will connect these two together, but I have to extend it until x is equal to -1 in here, but using the circle, okay, because this touch the -1, but not equal to. All right, so I'm using the circle for this one right here because x can be -1.01, right? Something like that, or -1.1. All right, so that's my fourth piece. Okay, this piece is f of x equal to 3 minus 2x. X is less than -1. Okay, and then the second piece, let's see what do we have. Second piece, we can have f of the 0, right? 0. So f of 0, this is -2. So that one is right here. And now we can have a f of the 1. Okay, f of the 1, this is -1. All right, so we have these two pieces. Okay, and then we can connect them together. All right, and then that's going to the greater than or equal to -1. So I also have to connect to the -1 in here. Actually, this one has an equal sign. So when x is -1, we actually have a -3, so right here. All right, so this one is -1 and -3. All right, so these 3 points should be all in one line. Okay. So that is how the graph will look like. And then you can go to look at how the graph will look like. You can maximize this one right here, right? So this looks like the right shape, you know, according to our this one. You just have to check a little bit detail in the number. Okay, this one don't look at the right one at all, right? So if you look at our, you know, just look at the A and B, this one doesn't look at the same shape. All right, and then you go to check a C and D to see which one. Let's examine this one, make it a little bit bigger. Let's see if this A look right, because it's kind of in the right direction. Okay, so in order to look at if this one is right or not, you want to check the number in here. Okay, so this number, this one right here, this is -1 and -3, right? So let's see, do we have that? Yes, this is -1. Okay, because this one is 6, so each one is 1. Each grid here is 1. All right, this is -6. So, and then this is -10, this is +10, so each one of them is 1, right? So this is -1 and -3, so that looks about right, okay? And then this one, when y is 0, when y is 0, x is equal to 2. So when y is 0, 1, 2, so yeah, so that's the right one. Okay, at least we look at this one is the right one. And then look at this one right here, when x equal to -1. Okay, if you put a x equal to -1 here, this should be, let's see, what's the equation? -1, if you x equal to -1, this should be 5. Okay, so this point, actually, if you look at this one right here, this is -1, this should be 5. How do you know this one is 5? You plug this x equal to -1 into this equation, but using the circle point, right? So if you have a -1 right here, this is gonna be 5, but it didn't touch this point, so you're gonna use the circle. All right, so this is -1 right here, and then this should be 5. So 1, 2, 3, 4, 5. Actually, this A is the correct answer. Okay, it looks like a correct, but it's exactly right. All right, so you can put these two together and then graph on your own. Sometimes people ask, is there any way I can put this whole thing in a calculator? Well, kind of. Okay, I can show you how to use a calculator if you really want to graph piecewise. One thing is if you have to limit the x condition. If you do not limit the x's, look at it. If I have a 3 minus 2x, okay, so what happened? If I graph 3 minus 2x, you're gonna graph the entire x value because this domain for x is, default is all real number, right? And then this one, you will graph this whole thing, but you will only choose the x is less than -1. So less than -1 should be right here. So that means the bottom part is gone, should be gone. So the only way I can do this one right here is I can put my condition, okay? How do you put a condition? You can using the divide sign at the end. And then using the parenthesis, make sure you indicate x is less than -1. In order for this one, you will have to go to the test. So second math is the test. And then you have a less than in here. Okay, less than -1. All right, and then make sure you close the parenthesis. So that means this is my condition. If you graph this one right here, look at it. It does stop right here. Okay, so it's stopped right there. So you have this condition in here. So that's how you look at that. Okay, and then the same thing if I graph y equal to x minus 2, x minus 2 in here. Okay, and then if I don't do anything, it will be graph all real number in here. All right. So I want x is greater than or equal to -1. But if you don't want to know how to put a condition, it's just kind of knowing, well, my x greater than or equal to -1 should be right here. Okay, right here, and then going to the right, that kind of thing. But you can put a condition right here, just like we did in here, using the divide sign. Okay, and then make sure you specify x value. So this time is greater than or equal to, right? Greater than or equal to, okay? -1. Make sure -1, you have to use the the one with the parenthesis. Okay, and then when I hit enter, when I graph, all right. So yeah, you will graph exactly the same as we did on paper. Okay, so you will just need to use a parenthesis and put a specific condition in here. All right, any questions? And then if you go to the second graph, you can see the table. Look at it. So for the y1, since you specifically say x should be less than or equal to -1, right? So when x is not less than or equal to -1, this will be giving you all error, right? And then the other similar with y2 because it's giving you an error because it cannot graph, okay? Because you specifically put a domain in here for the x. All right. Okay, this one is go back to 2.4, right? We said earlier, this one is similar to the one we did earlier, but facing up for the graphing. So you want to write down the equation for the lowest degree polynomial function with the graph and intercept showing in the figure, okay? Make sure the leading coefficient be either 1 or -1. So you can see this one, the lowest degree in here, this has a 2x-intercept. So I might just write down as a quadratic equation. All right. So the quadratic equation, I know actually this, you cannot really find a vertex in here. You know why? This one is telling you using the what? Using the intercepts. Okay, using the x and y intercept. because the vertex, let's see, how about the vertex? Vertex is not quite exact, okay? You can see this vertex in here is not quite exact integer. If it's not an exact integer, it will be a little bit harder to estimate, all right? So we do not know this is gonna be negative, looks like this will be negative 6 point something, right? So it will be hard to estimate in here. But I do have my x-intercept in here. And I also have my y-intercept in here, okay? So my x-intercept here, this one will be, this is 0. So this will be 1, right? And then that's negative 1, 2, 3, 4. Okay, so I have my x-intercept here is 1 and negative 4. I also have my y-intercept here is 1, 2, 3, 4, negative 4. Okay, so that's why I make this chapter a little bit more content because it does include quite a bit the quadratic and exponential and also the logarithm. Okay. The good news is I do allow you to have a one-page formula sheet, okay? So you can write down any formula you need in here. All right, so we have an x-intercept. And then we also have a y-intercept. Okay, how much is that? That is, we said earlier, this is negative 4, right? 1. Let me just go ahead and make sure we got it right. All right, so that's 0 in here. So that's 1 and 0. That's 1, 2, 3, 4. Yeah, so that's right. And then that's 1, 2, 3, 4, negative 4. Okay, 0 and negative 4. Okay, so A will be equal to 1 or A equal to negative 1. Oh, this is facing up, right? So facing up, A should be what?
Positive.
Positive, yeah. A should be positive, okay? So A is positive in here. All right, so now how do we do this one? Oh, we cannot find a vertex, so I'm gonna using f of x equal to ax squared plus bx plus c, this equation. Okay, so I'm gonna set up the 3 equation and then find the ABC. All right. Okay, so my x-intercept, that means y is 0, and then the x will be equal to 1. So this will be a 1 squared plus b times 1 plus c, right? Or just a plus b plus c will be equal to 0. Look at that. 1 squared is this one. So I already have a first equation. And then plug the second equation here. F of the negative 4 is 0, right? So this one is f of the 1 is 0. Okay. All right. So my y is 0 and x will be negative 4. Okay. So this is square in here will be positive. So that's 16a minus 4b plus c equal to 0. All right. And then this one is y-intercept. So that means my x equal to 0, and then this will be equal to 4, right? So when x is 0, y is equal to negative 4. So that's a times 0 squared, b times 0 plus c. So that's 0, that's 0. So actually this one giving you my c here is negative 4, basically. All right. Okay, so let's see what we have here for this. Make sure the leading coefficient be either 1 or negative 1. All right, so we already said A will be equal to 1, right? So we say A equal to 1. And then from here, I can find a B. Okay, my C here equal to negative 4. So 1 plus B minus negative 4 equal to 0. So my B here will be equal to 3, right? 1 minus negative 4, negative 3, you add a 3 on both sides. So my A here is 1, my B here is 3, my C here is -4. Okay, we can double check the second one to see if it's correct. Okay, so 16 times 1, -16 plus C here, 16. Hold on. No. All right. This one is intercept. X is -4, 16. Let's see, 16 times 1 minus 4. Oh, yeah, I plugged the wrong one here. I plugged a B for the C. So B here is 3, right? And then plus C here, plus C is -4. So that's 16 minus 12 minus 4. So that is equal to 0. So that's exactly right. Okay, so we actually do not need this second one in order to find the B, but this one we can just double check, okay? That kind of thing. So using A equal to -1 is really easy, all right? So now we have A equal to 1, so my function here will be A is 1, so plug it in, so this will be x squared, right? And then B here is 3, so that's plus 3x, plus C is -4. So that's my equation, okay? That's the equation in here. That's the f(x) equation, the polynomial. Okay. All right. So you're using the general equation instead of using the vertex, because this one is using the intercept to solve, but not using the vertex. The vertex here is not an integer. Okay. All right, number 13, let's see, the following graph is a result of applying a sequence of transformation to the graph of one of the 6 basic functions. Okay, so we can have a, moving up, moving down, moving to the left, moving to the right, right? So identify the function. Does this one look the absolute value or the Q loop or the X square or whatever, okay? Write the equation for the graph, okay? Identify this one right here. So if you look at this one, let's make it a little bit bigger. All right, so how does this one look like to you? Does this one look like the absolute value of x? Identify the basic function. One of the 6 basic functions. So what are those 6 basic functions in here? Okay, so let's see what is the 6th basic function. The 6th basic function, okay, will be f of x or y equal f of x equal to x or y equal to x. This is called identity function. So what's the identity here? That means y and x are always the same. Okay, so that is identity. Y and x always the same. The second one right here is y equal to absolute value of x. All right, so this one is like a b, okay? Y equal to. All right, so that is y equal to absolute value of x. So like a, a little bit like a quadratic facing up, right? And then if I have a y equal to x squared, how does it look like? Now this one is a curve, okay? This one is a straight line for the absolute value. This one is a curve. It's called a parabola, right? And then this one I can move up, can move down. I can have f of x equal to negative x squared, right? So if it's negative, this is gonna be facing down. Okay, this is gonna be facing down, that kind of thing. Actually, this is the same thing. If I have a f of x equal to absolute value, negative of absolute value, this will be facing down as well. Okay, so that's the basic function. Number 5, if I have a y equal to x cubed, how does that look like? Well, the positive one, this will be in a 1 and 3. Okay, so that will be a curve. That would be 1 and 3. If I have a y equal to negative x cubed, this will be right here, will be 2 and 4. All right, so this will be y equal to negative x cubed. So those are the basic function in this kind of situation, right? And then you also have a y equal to square root of x. Okay, so y equal to square root of x will be something like that. All right, so those are the basic function in here. The good thing is if you really do not know the basic function, at least you can put this function in a calculator, right? And it will graph for you, okay? But I usually tell people, say, hey, if you want to move on to the pre-cal to calculus, you want to remember all this basic function, okay? Because a lot of university, they don't allow you to use a calculator in a calculus class. So that means you will need to kind of remember these basic functions so can save you time. All right. Okay, so let's see, how does this one look like? And I have an ABC right here. Okay, so this one, like I said, it didn't print the whole thing. So you have an ABC, A, B, C, D, E in here. All right. So this one is right here. It didn't show in here. But how does this look like? Does it look like f of, apparently it's not f of x equal to x, right? And it's not an absolute either. And this is Q loop, okay. How does a Q loop look like? All right, so if I have a y equal to Q loop of x, one thing, the Q loop here is R loop. So this is R loop. R loop x can be anything. So this will be right here and then right here. All right, so that's y equal to Q loop of x. Okay, Q loop of x, x can be negative, x can be negative, x can be positive. All right, and if you do not know, you can put in a calculator. Okay, so let's go to the calculator to see how the Q loop look like. You can have a square root, right? So this is in here, you have a square root. We graphed it earlier. That's the square root, okay? And then we're gonna have a Q loop. All right, Q loop here is you have to go to math. All right, and then there's a Q loop right here. Okay, this is any root. Okay, so we can graph the Q loop, which is the red one, right? So the Q loop x can be negative, can be positive, can be all real number. But the square root, that's why the square root, the even root, you have a limited domain. Okay, so that is you can use in the calculator as well. So this one looks like a y equal to x squared transform. Okay, and then transform to where? Let's see where's the vertex. Okay, the vertex here is moving to the right. So you have a 1, 2, so looks like a moving right for 2 units, and then also moving down for 2 units in here. Okay, so moving, you have a x squared, right? You have a y equal to x squared moving to the right for 2 units and then moving down for 2 units. Okay, so we're gonna have a y equal to x minus h squared plus k. Basically, it's kind of like the vertex in here. So your vertex here is 2 and negative 2 because moving to the right. All right. So you're gonna have a y is x minus 2 squared and then plus k. K here is negative 2. Okay, so basically this will be x minus 2 squared minus 2. All right. Any questions? Okay, so that is the function moving in here, right? So write down the equation for this graph, okay? Number 14, how can you tell the vertex form whether a quadratic function has two real zeros, okay? Has two real zeros. Well, we said earlier, if you have a two real zero, if we have a, remember, if we have a ax squared plus bx plus c, if you have a b squared minus 4ac greater than 0, this you will get two real zeros, okay? But if you write down this form, so this is a little bit tricky. If you write down this form, how do you write down this has two real zeros? That means it will cross the x-intercept twice. So if this one, or if a is less than 0, it will be this one right here, right? So you're gonna have two of them in here, okay? So in order for this to be 0, let's see how can we choose the answer in here. The quadratic function is if a is positive, k is 0, and h is not 0. All right, so when this is positive, so that means facing up, right? Facing up, and then h is not 0, okay? H is not 0. That means x minus h, it won't be 0, right? So a apparently is okay. All right. Let's see if it's okay, if it's complete or not. Okay, let's look at the b. Quadratic function, if this a is greater than 0, so that means facing up, right? And k is greater than 0. All right, and a is less than 0, that means facing down. K is less than 0. Well, this one, I think, you know, if you have a h equal to 0, right? So I think this one didn't specify the h, okay? So if I want this one has a two solution, okay? If I make a, on the x-intercept, this whole thing will be 0. Okay, my y will be 0. All right, so if I solve for this one right here, this will be equal to negative k, right? And then that means my x minus h squared will be negative k over a. All right. And then this whole thing, you want to make sure this whole thing is positive, is greater than 0. If this whole thing is equal to 0, it will be only just one real. Okay. If this whole thing is greater than 0, we have a two real. All right. So because we're gonna have a x minus h if you take the square root. All right. And then I solve for x here, take the square root, you need to have a plus minus, right? Plus minus. Okay, so let's become this one right here. So it doesn't matter, actually it doesn't matter h is 0 or not. As long as this one is have a two solution, I will still have a two real. Okay, so this one is a tricky question. But I want to make sure my negative k over a is greater than 0. Okay, so in order for this to be greater than 0, let's see what do we have. We have if a is positive, k is positive. And then if they both are positive, you have a negative outside, so this won't be true. So this one is wrong, okay? If a is positive, k is negative, all right? And then you have a negative outside, so this one is, this part is okay, all right? A is negative, K is positive. Actually, this part is also okay. All right. So I think we have All right, and then let's look at our A in here. Our A in here, A is positive, K is positive. Not really, this won't be positive, right? So the correct answer should be C in here. Quadratic has two real. If A is less than 0, K is less than 0. Let's see if this is correct. If A is less than 0, K is less than 0, and then you have a negative, you're going to have a 3 negative here. 3 negative here, it won't be positive. Okay? So, so this one is incorrect. So the best answer here will be the C. Okay? We want to also make sure they're all complete. The best answer here will be C. Okay? One of them must be negative because you have this outside, and can only one is negative in order to make a correct answer. All right, so that's a tricky one for this one. Okay, and of course, this one trying to test your analytical skill, right? So you just have to analyze it using this quadratic equation to solve for x. Okay, so if I use this one to solve for x, make this equal to 0 in order to solve for x. This will be minus k, and then you divide by a. All right. Okay, any question about this one? Okay, number 15 here is the fourth section, so should be the easiest one, right? Using the following graph function to determine the y to the nearest integer of y of f3. So that means you want to do x equal to 3 and how much is y. So this is just reading the graph, okay? Reading the graph, only find x equal to 3, how much is y. So you can zoom in as much as possible, okay? So when x equal to 3, so that's 1, 2, 3 right here, right? So when x equal to 3, how much is the y? So you have a reading this one right here. So y here, let's see, how much is that? So that's 1, 2, 3, 4, 5, 6, 7. So there's like a -7 in here, okay? -7, probably -7 point something. Probably not quite exact -7, right? A little bit down in here. So I would just say probably -7.1. If you estimate into -7.2, should be still right. Okay, but this is not a half, so I'm not going to estimate into -7.3. So I'll just keep -7.1. Okay, a little bit down here, not quite exact integer. All right. I'm sorry. It said round to the nearest integer. Okay, all right. Round to the nearest integer. Okay, so nearest integer will be -7. All right. Yeah, sometimes you just have to read the question requirement very carefully, right? It said round to the nearest integer, right? Okay, so yeah, round to the nearest integer. So integer here will be -7. All right. Yeah, apparently this one is a little bit down than that, but you want to round to the nearest integer. All right, that's all. You also get some answer at the end. So that is all the review I have. This pretty much not identical. Your number gonna be different than the test, of course, but it's giving you a pretty complete review. For the concept covers, okay, not quite exactly the same number in a question. Of course, in math you always change the number, but the question type pretty much we cover in this review. Okay, any questions? Does anyone have any questions? Okay, so one thing is this test does cover quite a bit of the content in here, okay? So we are allowed to have a 1 page of the formula sheet. That you prepare on your own will be 1 page. So you don't put it into 3 or 4 pages in the whole notebook, okay? Will be just 1 page of formulas. All right, that's it for today. I'm going to stop the recording.